Let's get started. So, who almost tripped and broke their butt this morning? I almost ate it, seriously. I'm like doing the dance, right? Trying to stay on my feet. Oh man, I guess that's the problem with so much snow. When you get a thaw, then it freezes overnight. That was very frightening for me. So some announcements to lead everything off. Problem set 2 was due this past Sunday, and I think what happened was, because of the schedule, a lot of you forgot that it was due. So only 129 of you did it on time, compared to 157 who did problem set number 1. So I suggest what you do is maybe put in your calendars on your smartphones how pretty much every Sunday the problem sets are due between now and the end of the term. And I apologize for not being able to remind you about these things, but they're in the syllabus, and it's hard for me to kind of keep on top of everything, just like it is for you. But I think that was the issue. If you missed problem sets 1 and 2, it's not the end of the world. There will be 136 total points possible over the 12 problem sets during the term, and 14 of those points were on the first 2 problem sets. So we've gone only about 10% of the way through. And so if you miss them, it's not great, but you will have ample time to make it up. The average student typically gets about 80% of the points on the problem set. So if you can start doing them now and get all your points from now on out, I think you'll be just fine. There was a question just before class from a student about which score do you get when you take the problem set multiple times, and the answer is the last one. So the last time you finish that particular problem set on time, if it's before the deadline, is that's the number of points that you get. So you can take it as many times as you want, but try to remember the answers, I guess, if you get them right, if you take it over and over again. They are still available even after the due date, as many of you have seen. I encourage you to go ahead and do them after the due date if you have not done them, just for your own practice. But that they can use them for review, but as the syllabus states, you get credit only if it's done on time. So please do them on time. Problem set 3 is due this Sunday by midnight, and problem set 4, which is the last one before the midterm, is due a week from this Sunday, which is already March. We are rapidly marching through spring here. Questions about the problem set? Yes? Yes, the question was, do we do an in-class review prior to the midterm? And the answer is yes. That's coming up on the next slide, I think, yes. Other questions? Okay. So the midterm is fast approaching. It is currently scheduled for Monday, March 10th. If we are struggling with the material, and the good thing is that I've got your iClicker responses to help me ascertain whether we're struggling or not, we might delay it until that Wednesday. But for now, the review session is the previous Wednesday, and the midterm will be on Monday, March 10th. For extra credit on the midterm exam that we take that day, on Wednesday, March 5th, we'll have this in-class review. That's the previous Wednesday. And anyone who downloads the Spring 2011 midterm exam, completes it, and turns it in, you can turn it today if you want, or last week. Anytime on or before that Wednesday of the review session, you'll get 5 points of extra credit on this year's midterm. Please, just for saving trees and paper and saving my back, because I will have to carry them, please consider printing it out double-sided to save paper and space. If you are interested in trying to fill it out electronically or something and emailing it to me, that would probably be fine. I just need to have evidence that you have taken the time to look at that midterm and think about the problems. That's the objective here, to give you extra credit for taking more of your valuable time. I recognize that it's valuable, and so I'm rewarding it, to look at the past midterm and try to work through it, because the exams are hard. They are not multiple choice, and they are new material each time, so they require some preparation. So please print out double-sided if you can. Please, so this only happened once, but please do not turn in the answer key. The answer key is available to you. You may look at it at any time, but please don't turn in the answer key. That will not give you 5 points of extra credit. That has only happened once, so I say it as a joke, basically, that somebody actually did that, and it was pretty funny. We will go over that midterm in the review session, as well as any other questions that you have on the 5th. Any questions about this policy of the extra credit? Yes.
So just handing it in is the credit, not getting every single one right?
That's exactly right. The question is just handing it in is the extra credit, not getting the questions right, and the answer is exactly yes. You know, I wish I had more time to give you more exams. Well, you don't, right? And grade them, but I don't have time to grade another exam. So all this is you're filling it out. And I hope that in the process of writing something for each of the answers, you will think about it. But I don't have time to grade it. I wish that I did. You probably are happy I don't, because it's not, you know, it's not graded. You just have to fill it out and turn it in. So other questions about this? Yes. Good question. Where do we find the exam? The spring 2011 exam and all of the past exams are on Blackboard. And if you go to the course's Blackboard site, if you look under class materials on the left-hand side of the navigation pane, it should be right near assignments. That's where the problem sets are. And so click into course materials and you should see them there. Also up there are, of course, the slides and the class videos, or rather links to the videos, and so on and so forth. Other questions? Okay. A couple of things. So this is a very busy picture. I saw this on Twitter. That was another thing, as a student before class mentioned that he was following my Twitter feed. And I follow a bunch of other people on Twitter, and this is not something I noticed. This is something a very smart economist whom I follow on Twitter noticed. And this is hard to read for you. I didn't put it in the slides that were up last night, so you may not be able to see it. What this is an index. So the number that you read off is, say if it's 105, that means that our real GDP per working age population, or roughly, you know, GDP per person, more or less, is 5% above, say, what it was in the peak, which would have been 2007, I think. There it is, 2007, 2008 banking crisis. So what we're doing is everybody starts from the same, you know, starting point, which actually varies in time a little bit for these different countries. Here is the poor Ukraine that just absolutely fell off a cliff in terms of GDP per capita because of the Great Recession. So this is a reduction of something almost approaching 80% in Ukrainian GDP per capita. That's just enormous. I mean, that's just staggering to me. For many other countries, the reduction was more like 5%, and we are in there. The blue circle line is us. That's the United States, and we end up here. Germany entered it later. That's why they have fewer data points. They have also done quite well and did better quicker and are currently above where we are. But look at this. Germany and the US are above this black line at 100. And everybody else, the UK, Spain, Netherlands, France, Portugal, Iceland, Ireland, Italy, Greece, did I say the Ukraine, are all below it. What does that mean? All of these countries in you know, these advanced industrialized countries, with the possible exception of the Ukraine, are beneath their pre-crisis levels of GDP per person, which is just sad, staggering, shocking. And, you know, to be honest, it should make you wonder who is in charge and why are they bungling this so much? It makes us look relatively good by comparison. And if you're wondering where this comes from, the answer is it comes out of the Obama administration. That, you know, they pointed this out as basically a way of saying, you know, we've actually done a pretty darn good job in the United States, and we have. It is absolutely scary what has been happening in other countries, however. So this is stuff that we'll be talking about in the second half of the course, but I wanted to mention it because it just came out over Twitter a couple of days ago. Any questions about this? It is what it is, right? I kind of figured you might not have any questions. Okay. What are we going to do today? I wanted to do some iClickers here to begin with, but let me just, again, show you the overview. We're covering Chapter 5, which is the solo growth model, and this is the most important chapter probably in the entire course. Most definitely for the midterm, and again, I think I have said this before, you will probably see Chapter 5, the solo growth model, on the final exam also. It almost always makes it there as well, so it's very important. We're going to ask and answer this question: what does the solo model tell us about how an economy grows over time? What is a steady state? It's a strange term, but it's another way of thinking about an equilibrium, which is a term you probably are familiar with. We'll talk about what stuff affects the steady state and what if the stuff that affects the steady state then changes. What's the story with that? We'll talk about transition dynamics that characterize movement toward the steady state. So this is, the extra complication here is that the Solow model is something that explicitly accounts for the passage of time. And that's very rare in economics at the undergraduate level. You guys have thought about supply and demand. There's no obvious way in which time kind of factors into that, where you're just at the equilibrium, right? Bam, you know, it just happens immediately. That's not quite the same here in the Solow model. We'll talk about what the Solow model helps us understand. And your favorite, we will talk about, you know, in graphs, we'll talk about shifts in curves versus movement along curves. And if you're crestfallen, I sympathize, because this was one of the hardest things I ever tackled when I was an undergraduate in economics. I think it's very confusing. And we will try to make it less confusing, but it is a confusing thing. And we'll talk about some of the math of the steady state, although I think actually we're doing most of the graphs today, and I think that the math will be next time. The math will be on the midterm and the final, I guarantee. The graphing will also be. The good news is that if you like graphs better, this will help you, because you can do the graphs. If you still need to learn the math, but you could probably, this is actually true. I think you could probably get a C- in the course if you can't understand the math, which, you know, some people can. You're not born knowing math. Anyway, so just a heads up about that. Yes, questions? The question was, does the book make it easier to understand the math? Is that right? I don't know. I guess I would say probably not. I don't think it does make it easier. I think what makes it easier to understand the math is having a personal history of understanding algebra and the math. And that is something you can't obtain except by practice. Yeah, I think that's the best answer, but I don't know. It's a good question. Other questions? If it's at all, you know, a comforting fact, you can pass the course and not know the math. It's just harder. If you're having trouble with algebra, I think it's, you know, practice is what's going to help you, and you can get practice in my office hours, in Drew's, the TA's office hours, in tutoring. Drew does tutoring. Other students do tutoring. You can get practice talking with your friends, but, you know, this is a challenging thing. Other questions? Okay, so if you could take out your eye clickers, I mean for this to be sort of an opinion poll. I'm not sure that we can or should move back. I just wanted to gauge your sense about this. I have noticed, and I will promise to you that I am more affected by the heat than you are. I sweat like a pig. It's something I really don't like about my body. And so I am going to be more affected by the heat than you, but it is possibly the case that Kylie is hotter than Remsen. I really guess I don't know. And so, here, let me start polling. I'm sorry, I haven't started it yet. So I thought I'd ask if the projector gets fixed over there. They told me yesterday that it actually would get fixed sometime soon, which I was surprised about. I see somebody fanning, and I mean, I'm really hot myself. To help, you can try opening the doors and propping them open with something up there. I have done that with this one. Other than that, I have nothing but sympathy. Kylie is just like this, I have found. It's just an oven. If you were around this past fall, I just canceled class sometimes because it was so hot. So I guess if you want me to cancel class, then you should vote to stay in Kylie. I don't know. All right, so let me stop polling in 5, 4, 3, 2, 1. And let's see what your thoughts are about this. And so most people prefer, so the majority prefer to stay here. Some would like Remsen and some just don't care. Okay, and so I think we will stay here unless things get really beastly. But if, you know, like I said, if things are so bad in this room that we cannot hold class without dying, then we'll cancel class. I mean, I guarantee that we will not suffer heat stroke and have bad things happen. Okay, so there's my pointer. All right, let me take that away. I think I will not open this up actually for voting because this is an interesting topic I thought I would mention. I couldn't stop thinking about it this morning, so I'm not going to open voting for this, and you can probably see why. Shia LaBeouf is a film star, and so you might wonder, what is this question about? I didn't want to go into details. If you have a smartphone, you can just Google it. You can also look at the New York Times today. So his fellow actor, James Franco, who's kind of a remarkable guy, actually. I don't know how many advanced degrees he has, but he has an op-ed piece in the New York Times, which is pretty sweet. And so what is he writing about? Well, he's writing about Shia LaBeouf, and whose name, incidentally, is a misspelling of French, the beef. Did you know that? It actually is. What happened? Well, we don't know. He was a child star, and some of the things that seem to be happening make it look like he might, the poor thing, maybe be losing his marbles, and that's not funny at all. It's a sad fact that a lot of child stars go through this stuff. Okay, so what happened? Let me tell you. He plagiarized a cartoonist's plot and actual dialogue and made it into a small independent feature film, a small little tiny film, right? He totally plagiarized it. So that's not really very cool, right? And so that was the point here that, well, maybe he should have taken econ201 and done the plagiarism quiz a couple of times so that you're not supposed to do that. And then what happened was, well, somebody pointed out that he apologized for it, and in the apology, he seemed to have plagiarized from Yahoo Answers. And so this is like really meta, right? But then the thing is, well, is all of this an accident, or is it intentional? And is he maybe trying to point out the inherently vampiric nature of celebrity media? And his point would be, if we are to go that far, that celebrity media basically plagiarize their celebrities' lives, right? Not really. I mean, a good celebrity media person doesn't copy from another celebrity media person, but the point is that, well, they're not really producing anything new. They're just following people like Shia LaBeouf around and just sort of, reporting everything that he does, including if it's crazy stuff like this. And so I mean, this will really do your head in if you keep thinking about this. So I couldn't resist putting this up here, but I thought, well, let's not vote because I don't know, and it's not funny to have mental health issues, which you could interpret this as being that. Kind of like how, so if you remember, Joaquin Phoenix did this, and it looked like he was melting down, and then like 3 years later, it turns out it was all just method acting. And that's what he said. But, then there's Britney Spears, who really was mentally unhealthy. And I don't know. So it makes me a little bit feeling strange about the whole thing. But I thought I'd mention this because it is an issue about plagiarism, which is just more and more timely these days because we all have access to everything on the internet, and you should be aware of the challenges around it. And then if you like, you should get involved thinking about, is this method acting, and are they just doing a hilarious, mind, messing up with us? And that certainly could be. Yeah. Anybody heard about this before today? This is weird. Yeah, I was just like, whoa, that happened? And I was like, yeah, it did. Just recently, like the last month or so. All right, so crazy stuff. All right, let's do an I-clicker question, and here's the question. And this might be a little difficult for you to think about. A country's capital stock consists of the buildings, the bridges, computers, and other machinery that it uses in production. Now, the question may seem a little strange, but the question is, can the capital stock change quickly? What do we mean by that? Well, think about things in economics that can change quickly. Prices can change really quickly, right? If suppliers see that there are a lot more demanders showing up, they can just raise their prices. If they see that there are fewer, they can just reduce their prices. Prices can change pretty quickly. Not always, but pretty quickly. So the question is capital something that can change quickly like that or not? And so the answer A is yes, it can. Capital goods are just like any other produced goods, like potato chips or movie tickets. B, no, it can't. Capital goods take time to produce. C, most of the time, no, but sometimes yes. You could think of capital being quickly destroyed or reduced in, say, a natural disaster, or quickly added through trade. Suppose you just bought a piece of capital that was already built in some other country, or they just gave it to you and it just showed up. D answers A and C are the best, or E answers B and C are the best. As always, feel free to discuss with your friends. Okay, so let's stop polling in 5, 4, 3, 2, 1. So I think the best answer here is answer E. And of course, you would then get partial credit if you answered either B or C. C is, I suppose, probably the best one because it actually includes part of B here in C. So I guess you could answer just C and B also just correct. Answer A is not really right at all. So I think you basically got it, that E is the best. C is quite a good answer. D's not so good, and I fooled you that way. Sometimes, right, if you write the, anyway, it's, yeah, the old trick. Okay, so good job. The capital stock is, filled with stuff that produces other stuff, and typically it takes time to change that in large amounts. Prices change very quickly. Another thing that you could think of changing fairly quickly is the actual level of output, which can change, if technology or labor were to change quickly, and labor can change rather quickly, could just all leave, right? If everybody just left the country, you would imagine GDP changing very quickly. So related to this then, here's another question to kind of make you think a little bit about what the deal is. I'm sorry, I put up the graph, I beg your pardon. Sorry, so let me click this open for polling. The question is, GDP is a function of technology, capital, and labor in this way. We talked about how capital generally can't really change quickly. The question is, can GDP change quickly? In answer A, yes, it can. Technology can change quickly if there's a new breakthrough in ideas or techniques. B, no, it can't, because capital can't typically change quickly. Capital takes time to produce, and output depends on capital. Answer C, yes, it can. Labor can change quickly if people suddenly die or immigrate. And then D is A and C, and E is B and C. Okay, so let's stop polling in 5, 4, 3, 2, 1. Yeah, I like doing this because I think it gets you thinking about the topics, and I apologize for doing this because it makes you stare really hard at this and try to think about the minute details in the statements. And that's the problem with multiple choice questions, it seems to me, that you can take a poll, but man, figuring the details is tough. My thinking here was that A is definitely true. Technology can change quickly. If there's some new development that can very quickly be transmitted to, like, farmers about how to grow their crops better. So that's definitely true. A is true. B is a statement, no, it can't. Capital takes time to produce, and output depends on capital. Output does depend on capital, and capital also takes time to produce, but output also depends on ideas or technology and also on labor. So it's not a very good answer. I don't think B is a particularly good answer. C is a lot like A. Labor can change quickly and output depends on labor. People can quickly die. We had this crazy example of the Black Death last time. We also had, and will have, this story about immigration in which labor can change rather quickly. So I think both answers A and C are good, and so I would go for answer D. But any of those sorts of things, the combination, and so most of you answered D, and I think that's the best answer indeed. Yeah. B is somewhat true, but not all that great. Okay. Questions? Yeah. Yes. Sorry?
Like analytical to the point where you think about how, like, you can't just, let's say a big company can't just change over when there's a breakthrough technology.
Yes. Okay. Yes. Let me try to summarize what you just said. Gosh, Professor Edwards, this is a very simplified view of the world, and one could argue different ways, and I think that is absolutely right. This is why I don't like multiple choice questions, is because they are somewhat dependent on the view of the person writing and grading them, I think. You will see on the exams that you'll write for the course, you have broader latitude to make your argument, and you could make some more detailed argument about something, and you'd at least get partial credit if you're convincing, which most often people are, even if I think they're kind of incorrect on some level. Yes, that's exactly right. Okay. Let's do one more, and this is going to be hard. If you've read ahead, it will be less hard. Think about how saving produces new capital through investment. That's the story of the Solow model. And remember that output equals this, y is equal to a times k to the 1/3 times L to the 2/3. And my hint is that, saving is not really in this, right? If the saving rate rises, do you think that would shift the output curve, or would it produce a movement along the output curve? Saving increases capital, and capital's right here. I guess the issue is, how do we visualize the output curve? It's a thing in space, and so you need to know what the axes are. And the answer is this axis is capital, and this axis is output. So answer A is, well, it would be a shift in the output curve because output would be higher for every level of capital. Or do you think it'd be a movement along the output curve because a rise in the saving rate would produce more capital, and output is a function of capital? So that's kind of the crux of it all. Or answer C, would it be both? Answer D, would it be neither? Or answer E, would we cry for our mommies? Because this is kind of one of the tough things in economics. I often cried for my mommy when I was in college. Okay, so this is a very tough question. I actually cried more in graduate school for my mommy, but I cried in college too. So let's stop poll. I'm sorry, I think I stopped polling before telling you. I apologize for not giving you a countdown. Sorry, let me just keep myself honest. The best answer is B, a movement along the curve, because a change in the saving rate would result in having more capital. Capital is the thing that's on this axis. Output is a function of capital. So this curve is the function output of capital and other things. And so it's not going to be a shift in the output curve. It's going to be a movement along the curve triggered by having more capital. Answer B is correct, and that's what most of you responded. Very good job. And 4 of you asked for your mommies, and I want to ask for mine often too. That's cool. I think there are things that do both. Ultimately, I guess, but it's rare to see both combined, and it's also, well, you could see neither actually. That's not a bad guess, but the best answer is B. Okay, so we're going to see that, but I'm happy to take questions if you have them. It's just that if this isn't clear, hopefully it will be clear after this and next time. Any questions? Okay. James Franco, all right. Okay, I've got to get that thing to go away. All right, so let's do some more boring sort of presentation of this. What's happening in the Solow model, this metaphor is that the farm produces corn, and the farmers have to save some of the corn so that they get some corn produced next year. That's kind of the critical thing. That there has to be some saving out of this. They've got a production function that is familiar. It's the same thing corn as before. Corn is produced with capital and labor, but then this is the twist. And this is where this expenditure side look at GDP comes in. The corn output, so this is kind of what the production function is doing. And then this is what the planners, if you like, or the demanders, or the savers, however you want to call them, the people who run the farm, they're thinking about what to do with what they've produced. And the answer is it's got to either be consumption or investment of the corn. Investment produces new capital that increases the capital stock. Now, the way in which this metaphor is kind of rough is that, so the corn that you don't eat is the seed for next year's crop, but you use up all of that, right, in planting the next year's crop, and then it grows, and then you're out of luck again. You've got to then save new corn. That's a little different from the way that capital actually works in the real world. Say, take this room, and well, take all of Kiley Hall, right? Is Kiley used up after we're done with it this semester? Does it just break and fall apart? No, it sticks around. Is Kiley as nice as it was in 1950 or whatever it was that they opened the place? No, it's kind of dingier and not so nice. But there are upgrades, right? Like this thing probably didn't exist in quite the same way. I couldn't plug it in here back in 1950. I would have to have, you know how they used to do this, right? You actually had to make slides and have somebody running the slide projector back there in the back, and you'd say, next slide. And they weren't, you know, this, they were actually slides, which are, I mean, I was exposed to those as a kid, but I grew up in the 70s, and you probably have never even seen a slide, right? I mean, talk about old technology. That's old stuff. So in the real world, what happens is we might call it a difference equation, some kind of equation of motion. If you remember from physics, if you took physics that talked about this, there are a bunch of equations in physics that kind of look like this. They might be differential equations that are actually in calculus, but it's some kind of way of describing how things flow over time. And so in the real world, the capital stock does this. It evolves according to what it was last period. So the capital stock today is what it was yesterday at time t, plus the new investment, which produces this new capital. And then the critical thing is that there's depreciation, which is a share of capital that breaks during this period because we used it. So if you recall, at the very end of last class, I said, well, how to think about this. So 10% of your capital stock deteriorates. Suppose you bought a car, let's just make it easy. You bought a car for $10,000. When does it lose the most value? And the answer is when you drive it off the lot, right? Right immediately, it loses the most value. Well, a way to make that intuition help you with this is think about this 10% depreciation rate on a $10,000 car. After 1 year, if the car was $10,000 to begin with, how much is it worth after 1 year at a 10% depreciation rate? What's 10% of 10,000? 1,000, so the car is worth 9,000. After the end of the second year, what is the value of the car? That's a little harder. 9,000 times 10% is 900, and so you lose $900 of value after the second year. So you lost $1,000 in the first year of value, lost $900. That's how this is working, is that, you know, the biggest loss you get is in the first year, and then it sort of gradually depreciates. I can't resist, but just as a side note, of course, we usually think that driving a car will tend to result in depreciation. I think in New York, it turns out that just leaving it on the parked on the street will also result in the car's depreciation. At least that's what I have found. All right, so so here's the story. We can rewrite this a little bit to make it a statement that's a little easier to use about the change in the capital stock. So let's find a new equation for the change in the capital stock here. How do we see that? Well, the change in the capital stock is just the difference between kt plus 1 and kt. So if we subtract kt off of both sides, we'll find that the left-hand side is kt plus 1 minus kt, or just the difference in kt, the delta. So that's what delta typically means. It's the change in kt. Kt falls off of the right-hand side because we subtracted it from both sides. And now let's just drop the multiplication sign and just write it like this. This is a lot more easy to think about. So the change in the capital stock is the new investment minus the depreciation. Why do this? It will become handy later. Let me just also make this a little bit more intuitive. Think of the capital stock here as the value of your car. So if you want the value of your car to remain the same, well, it is depreciating. You have to conduct investments in the car. You have to take it into the shop and get the tires replaced, and you know, maybe the air conditioning is going. That's what the depreciation is, and so you have to get it fixed. So the new investment is the spending that you would conduct to keep the car in tip-top shape. And you know, maybe it's a bad metaphor because most of the time cars just lose value monotonically, but that's because we don't care, right? We're like, fine, let the car just lose value. I've got to use the car for driving, but I'm not going to invest so much in it that the thing gets souped up and gains in value over time. I mean, that would be silly. I use it just to get myself around, and I want it to look decent, so I'll give it a car wash now and again. So I guess that is sort of a challenge. In real life, though, the value of the capital stock could rise if the amount of investment were high enough. If you're actually adding to the value of the car so much with all, you're putting a spoiler on the back and you're getting the chrome, hubcaps and the chrome tailpipe and all that stuff, Our car actually, it's a Honda Civic, but it has this tiny little spoiler. It's kind of sweet. No, it's not. It's not. It's just what I tell myself that I'm sweet, but I'm not. All right. Okay, so how does this work? Let's just think about the numbers here and how this is actually going to go through. So suppose we start with a capital stock that begins at the value of 1,000. And each period investment is 200 units. So that's just an assumption here. Let's just suppose we're, the value of this thing, whatever it is, I guess it's a used car, and suppose we're pumping $200 each period into it, which is low for an annual payment, annual amount of money to pay on it for a used car, because usually they break down a lot more, and you have more like maybe 2,000 each year, I don't know. And suppose depreciation is 10%. What does this look like? Well, at time zero, the value of the car, say it's a used car, is $1,000. The new investment that year, so you go out and get a tailpipe and chrome it out and all that, is 200. The car depreciates by 10%, and so the change in the capital stock is the difference of these two things. I probably maybe should have put a minus sign here to make this a little more obvious. It's 200 minus 100, and that's equal to 100. That's the change in the capital stock, and that gets added to what we have. So the next period's capital stock, just for kicks, it's going to show up there and also down here, is 1,100. So this might make it a little bit more obvious. Suppose there's still $200 you spend on the value of your car, which miraculously is gaining in value. I mean, this is not realistic for a car, right? But so somehow we started off with 1,100, and we're adding another $200. Depreciation is actually a bit higher, which may seem counterintuitive, but the assumption is that exposing your car to New York City potholes and all this garbage, means that there's a 10% depreciation rate no matter how valuable your car is. Well, the depreciation now is actually a bit higher, right? Because the value of the car is higher, and so the amount that gets destroyed is sort of more valuable. Yes?
Why are you not taking the percentage of, why are you not adding what you added to the value? Meaning, why are you not taking 10% of 1,300?
Why, the question is, why are you not taking 10% of the 1,300? And the answer is, we are, okay, what is the 1,300? It would be,
if you're adding the input.
Yeah.
The new copy, the new
I
whatever.
honestly, it's a good question. I'm trying to think about how to answer that succinctly. You're almost basically raising the question of, are we in discrete or continuous time? And that's a very advanced question, so let's try not to go there. It helps just to, remember this. I don't think I've ever asked anybody to memorize this on an exam, but to recognize what this means. And you will agree with me here that your 10% is applied just to KT, right? Not to KT and IT. Okay, so if we can agree on that, right, that's the way the world works. I will write down the equation on the exam, and let's go ahead and leave that can of worms unopened. The change in the capital stock then, which is the difference of these two things, is now different. What's happening here? Well, the capital stock is growing. It's because investment is quite high relative to depreciation. But if this is just some constant number, what has happened now with this thing getting bigger? Well, depreciation is now a larger amount because the assumption is there's a constant rate of depreciation. That's fairly reasonable. And so what we're finding is that there's actually sort of a deceleration in capital. The thing is increasing, but at a decreasing rate. That kind of gives you some intuition for what, excuse me, is going to be happening in the Solo model. In period 2, we've added 90 units, and so we're now up to 1,190. The investment, supposing it's still 200, compared with depreciation, which is now 10% of 1,190, is 119, and so the difference there is smaller still. And so we can see that the capital stock is increasing, but at a decreasing rate. Right? That's rather familiar in the course. A lot of things do that. They are increasing and doing so at a decreasing rate, and that can happen. So eventually, what do you think is going to happen to KT in the future after a whole bunch of T's? Will it continue to grow, or will it fall, or will it stay the same eventually? Okay, so different opinions. It might fall, but nobody said continue to grow. I think a good answer is it probably is going to stay the same eventually after a while. And my argument would be, well, if this is 200, you can imagine this getting up to 200, and then what would happen to the capital stock? It would just stay the same. If the new investment is 200 and the total depreciation is also 200, it would just stay the same. And the very next period, it would be the same story. It would just stay the same, that kind of thing. That's hopefully, looking at the numbers can give you this intuition about what's going to be happening in the Solo model. That we're going to get a steady state, which is an equilibrium, where this has played itself out finally. Saving and depreciation have kind of counterbalanced each other perfectly and produced a capital stock that just stays exactly the same. Okay? Moving on. So what else have we got? Well, labor is going to be just given to us and exogenously fixed. So, there's a bar over the variable. That's what the textbook does, and that's a pretty good way of doing it. Now, the critical thing here is, what is the level of investment? And what we're going to do is harken back to this simple metaphor that farmers think about saving a particular share of their crop. They think about putting aside some fraction, little s, of income or of the crop that then becomes investment. And so in terms of the math, there's this little s bar, which is a numerical share. It's a number that is between 0 and 1. So 0.2 means that 20% of your income is saved and becomes investment. Okay? Well, let's list the equations that we've got in the model so far, and we're going to do some simplification. So there's a bunch. Here's the production function that you've seen a bunch of times. Here's the assumption about the labor supply being fixed at L bar. Incidentally, that actually doesn't have to be fixed at L bar, but it helps make things more easy to understand. And I've often thought that if I were to write the textbook, I probably would say, well, let's let L bar change. It's more realistic. There is population growth. And, in fact, it doesn't change things very much. And then we finally got these last two. So the most important one is this, but it's kind of an intermediate version. And the reason is, well, here is I, right? We've got I here and here in these two equations. And so when you see things that are in two equations, you can substitute and simplify a little bit if that's your fancy. The question, of course, is how to know when to do that, when to substitute. So IT, that's investment, appears in two of the equations. And we can combine these, and that produces then this other one. That is the thing that I'll be showing you on the exam and asking you to interpret. You in general can't solve this if you're ANSI to kind of solve for a closed form solution of K. You probably aren't, but in case you are, you typically can't. And the reason is it's one of these physics things. It's a difference thing that evolves over time. But this last equation now is really very helpful. And this is kind of all you need to know to get your head around the Solo model. Again, so on the previous slide, what were we talking about? Over a long period of time, what do you think might happen to the capital stock? Well, I said, the intuition is it might, slow down and stop growing. That's a statement about delta K, the change in the capital stock, being 0. Well, if delta K is equal to 0, what does this then say about S times Y as compared with D times K if delta K is equal to 0? Then they are equal, yeah. Then the two of them are equal. So if this thing is equal to 0, then Sy minus dk is equal to 0, and thus the two of them are equal. And it turns out that you can graph both of these two things. That's what we're going to do next. If in the steady state they are equal, that means that when you graph them, they intersect. And lo and behold, we have what you're familiar with, which is that in econ you've got a set of axes and a couple of lines, and where they intersect is the magic spot. And so the steady state is going to be where these two things are equal. This is kind of a big thing. The saving rate and the amount of saving is a big part of this. So is depreciation, and then it leads to a steady state. So what we're going to do primarily, but however not only, is we're going to use these things graphically to think about. Here's this key equation of motion, and there are two main pieces of this. There's saving, which is equal to investment here. And let me just put up all the points and then come back to this a little bit, because I do think it's a bit confusing. And then there's total depreciation, which is the depreciation rate times the level of capital. And it turns out that you can graph both of these two things together, and their intersection means that they are equal, and thus that the change in the capital stock is equal to 0. And that is going to be the steady state and the equilibrium. So there's a lot of material that we've just covered. Those of you who've read ahead are more familiar with this than those who have not. Let me just say the thing that I think may trip you up a little bit is this point that saving equals investment here. And you know, that's maybe not at all very obvious. Saving is, you know, the act of the farmers, you know, taking their corn, they're eating some of it, and they're taking their saved corn, and it becomes the seed corn next year. That's why the saving that they do actually becomes investment. In the real world, saving and investment seem like they're kind of different things to you and I. But you know, the reason why it becomes a little blurry with the definitions of these words is in fact it's not that different. So if you save money out of your paycheck, where does it go? You don't consume it, you save it, so it goes into a bank probably, yeah. And then the bank does what? It typically lends out your money. And to whom does it lend? Well, it lends to somebody else, but often a business, but it, you know, could lend to another person like you, maybe 20 years older or 10 years older, who maybe is buying a house with that lent money, right? The house is investment. It's actually capital investment if it's a new house, right? You purchase the thing. So it turns out that your money got directed by the bank into an investment activity. And so that's why the word investment to us often means, you know, you're investing in a firm, but that really means that you're taking your cash and giving it to the firm in exchange for a stock. And you could call that saving, and you could also call it investment. I think that's, along with Shia LaBeouf, that's one of the things that really gets my head all twisted around. And I hope that that was helpful. It may not be, but feel free to ask questions. In the Solow model, saving equals investment. Okay, so maybe we should move ahead and I'll show you the graph. Any questions? Okay. So the Solow model graphs these two things together on these axes here. So the capital stock is the x variable, or the horizontal variable. The vertical variables are going to be all things that are functions of the capital stock, and so here that's going to be total investment and total depreciation, or total saving and total depreciation. And just for kicks, so I have rewritten this and not told you in this way. So the change in the capital stock is equal to little s times y. Y is equal to a times k to the 1/3 times l to the 2/3. And then here is the depreciation part. So this is the same math as on the previous slide, but I have expanded it to help you think about this a little bit. What's happening to the saving rate? Well, we assume that that is constant. We also assume in the basic Solow model that A, the level of technology, is also constant. And we're assuming that the level of labor is constant. So L, A, and S are all constants, but K is not. That's the variable that appears right here. So this whole thing is a function of K. So is this also a function of K. So the depreciation rate D times K is also a function of K. That's the easy one to think about. How would you draw that if you had to? D times K. It's just a straight line, right, with slope D. So there it is. It's like you were graphing y is equal to 2x, right? The slope would be 2. The depreciation rate is the slope here of this thing. The thing that's a little tougher is the saving or investment line. Well, like before, when we graphed this last class, you know, the story about production possibilities, if you like, when productivity was changing and there were two different things that kind of looked, you know, like these big concave curves, just like that, the story with the saving curve is that it looks concave. And the reason is we've got capital to the 1/3 power. So as you increase capital, there are these diminishing returns to capital, and that's this point, that increasing capital alone, holding S, A, and L all constant, gets you a little bit more each time, but it was a whole lot more back here, and less and less and less and less and less. So the thing is concave and increasing. And where is the magic here? Well, it looks like a weird graph, but it's really very similar in some ways to supply and demand that you're sort of comfortable thinking about. The crossing is the magic point. The crossing is the steady state. It's where D times K is equal to S times Y. and thus the change in the capital stock is equal to 0. Okay, questions? Okay. Shall I advance the slide? Some of you are still writing, I think. Okay. All right, well, I've got a silly question, and then, you're welcome to vote on this. Why are we doing this? Well, Robert Solow won the Nobel Prize, so just be quiet. I don't know. I don't think that's a very good reason. This knowledge will make you a kinder, gentler person, possibly. This is training in how to learn advanced but parsimonious stuff. I don't know, or my favorite answer would be Jeter, and I'll just put that up there. I mean, I think the right answer is obviously Jeter. I mean, come on, we're all talking about him, right? Anyway. Silly question, fun times. This is training in how to learn advanced stuff. I think that's probably the best answer. Okay, all right. How about this question? Why is the steady state at the k star where delta k is equal to s times y minus d times k, which is equal to 0? So why is that the steady state? Now, it's obviously not A, why I said so. Is it because income equals capital and the saving rate equals the depreciation rate? That's answer B. Is it because the change in the capital stock equals 0? Is it because total saving is less than total depreciation? That's answer D. Or is it because total saving is greater than total depreciation? The protest vote is definitely A here. You really don't. Not if I haven't made it clear, it's just not clear. All right, so I'm going to stop polling in 5, 4, 3, 2, 1. Okay. So I think, yeah, the answer is A. Now I think the best answer is C. It's because the change in the let me just pull this away for a second. The change in the capital stock equals 0. The change in the capital stock equals 0 means the capital is where it is going to stay. It won't deviate from that, and that is the steady state. And it's defined by this math. Delta k is equal to s y minus dk, and it happens to be true that at that k star, I should have written it here actually, that is equal to 0. B is my deceptive answer, and many of you fell for it, and I'm sorry. That's the thing about multiple choice. Because income equals capital and the saving rate equals the depreciation rate, that could happen, but it is generally not true. It doesn't mean that it's never true, but it generally isn't true. That income isn't equal to capital. The two are distinct, and so they're generally not equal. And the saving rate could be equal to the depreciation rate, but it typically is not. So I fooled you there. It could be, but it most often isn't. And you get a steady state under conditions that are less restrictive than are stated there in answer B. Basically, the steady state happens when you get a change in the capital stock equal to 0. You did not go for D or E that much, which is good, and it's because D or E are stories about total saving being either less than or greater than total depreciation. Total saving is the new capital that gets produced. Total depreciation is the old stuff that breaks. So the steady state concept needs to be where they are precisely equal to one another. So if the word less or greater were rather equal, then those would be correct. Okay. Questions? I know this is really rather tough material and brand new. Any questions? The answer is C. The answer is C. And I will put these up on Blackboard with the answers circled, just like I have the other ones. Tough stuff, right? There's a reason he won the Nobel Prize for this. It was not all that obvious at all, and it's tough stuff. Let's talk a little bit about how everything works in the Solow economy here. What is interesting about this is an equilibrium where these things cross. You're used to thinking about equilibriums as being where the lines cross, but you're probably less used to thinking about, well, how do we get there? it turns out that in the Solow model, there is motion toward this equilibrium from either side. If we're down at some level of the capital stock that's down here, K0, at that point, the functional value in the red curve, the total saving, is this level. It's the intersection of this vertical line here, so the functional value of K0 is equal to this, and it's more than the functional value of the depreciation line. So that means that saving, which is equal to investment, is greater than depreciation there, and that means then that there's more saving than depreciation, and it's a story about the capital stock rising. So if you like the car metaphor, what's happening is you're taking the car into the shop a lot, you're having a lot of new stuff added to it, new tinted windows and all kinds of cool stuff. Right? That's what people pay for, right? It's like tinted windows and like good tires and, I don't know, like a Sirius satellite radio maybe, I don't know, I have no idea. Then, because delta K is positive, and it is mechanically, Sy is greater than dk at this point, that means that delta K is some positive number, and so we'll be moving to the right. That will be true all the way up until we get to the intersection. Imagine we might start on the other side of the intersection. Well, if we did, at that point, then the green is above the red, and we are in the red, if you like, to some extent. The saving, which is equal to investment, is now less than the total depreciation. Why? Well, we're above the steady state. The force of depreciation is linear, basically. 10% of your capital stock just gets destroyed all the time, and that's actually pretty realistic. So you would either have to increase your saving, to kind of make up for those losses, or suffer this reduction back to the steady state, basically. So delta K is negative because we're in this world where depreciation is higher than saving, and you can just see it visually there. So we're going to be pushed back to the left. So since delta K is negative, K is decreasing from K0 here back to K1, and that's going to happen all the way until we get to this steady state. So this is called the process of transition dynamics. Any capital stock that you start with, you're going to end up at this steady state K star, where delta K is equal to 0. At that value of K, these two forces are just perfectly balanced. Remember the example of spending $200 to soup up your car. Well, you increase the value of it, but the problem is that if 10% of it is being destroyed all the time, at some point you hit that limit, right? That you're adding to the value of the car, but because the thing breaks at a 10% rate, your new additions ultimately sort of peter out. And so no matter where we start then, this is going to be a slow process of transitioning, and that's why these little arrows are appearing, toward this steady state level of capital. Okay, so it's not what you're accustomed to seeing in econ 101 or 102, where everybody just always operates immediately at the equilibrium, the intersection of these things. Economies can be off of their steady states for quite some time, it turns out, and they will be transitioning through this process of transition dynamics toward the steady state. Yes? The question is, if you have too little saving and too much depreciation, would you not go back to the steady state? And the answer is you would, but it would be going down to the steady state, right? It's a good question. I think what you're getting confused about here is how, this is what you described. If you're at this point, right? So you're at K0 in this graph. There's too little saving. That's the level of the red line at that point. And too much depreciation. You're going to go to the steady state, but it's bad, right? You're going down to the steady state. You're going from K0 toward some K1, okay? So your intuition is exactly correct. I think what you maybe got hung up on there is that it's not always good to go to the steady state because it might be below where you are. It could be bad. It could be painful. So incidentally, and I think the textbook makes this point, and I don't think I have made this in the slides, you could think of this as being a basic model of foreign aid in the form of capital. if this represented a poor country and a rich country gave it an amount of capital that pushed it up to K0, so it pushed the amount of capital in this country above where the steady state was, well, the country gets more well off. We're coming to that. It has more capital. But the problem is that if depreciation is high, well, the green line is real steep. If the saving rate is low, then the red line is rather flat. There would be a low steady state. So if you gave foreign aid to a country and pushed it up to K0, the problem is over time the country will transition back to K1 and then finally the steady state. So that's in the textbook. On either side, you're going to be finding that there's motion toward the steady state in the middle. And so just for kicks, let me put this slow animation up there again. It's like the equilibrium in supply and demand, right? It's just that we have this argument for why you're getting there. And the answer has to do with the relative powers of saving versus depreciation. So it's a very good question. Other questions? Tough model, right? This is it. This is like the hardest part, basically, of the whole class. There are other hard parts, but this is kind of as hard as it gets, especially when you add in the math, which we haven't done yet, or not as much anyway. Let me, unfortunately, complicate it a bit more. There is also an output curve. There is also an output curve. So these are the two red and green lines that we just saw. Now, let me just draw them a little bit shorter so that we can also put this function of capital in there as well. And why do we do that? Well, capital is important, but it's not really in and of itself that important. We want to know about output, or GDP, and technically GDP per person. So we still have transition dynamics toward K star. So on either side, wherever you start, you're going to be headed there. And now we also have a mirror reflection of this up in the output curve. So if you're starting at some level of K star that's down here, you're going to start at some level of output that's roughly at that point, and you'll be transitioning up here. So this basically makes it clear. At this low level of K star, GDP is lower, excuse me. And so as capital gets accumulated through this process of saving, transition happens from this lower amount of GDP toward a higher amount. Why is this interesting? Well, a big one is in the following way. Countries can improve their GDP by increasing their saving rate. And if this is familiar to you, it should be, because we have seen this over the last several decades, especially in Southeast Asia, also in China. So suppose China starts at a level of GDP that is given by this Y star here. Suppose that the level of the saving rate is moderate, it's not real high yet. Suppose that China raises its domestic saving rate. And China or South Korea are very good examples of countries that did this. If the country raises the saving rate, well, the saving rate is this parameter here. If it raises the saving rate, what happens in the picture? Well, I've given it away, the cat's out of the bag. It shifts a curve. If you remember the iClicker question, it shifts the saving curve and not the output curve, it turns out. And the reason is, here's the math of the saving curve written out longhand like this. The math of the output curve is given up here. Do you see the saving rate in this math? No. That's why the output curve does not shift, but the saving curve, this red guy, does shift. What will happen? Well, China began at K star. This has occurred. The saving rate has risen. What will happen over time? Transition toward a new steady state, K double star. And so these are all overlapping here. But so here is this new level of capital. It makes intuitive sense, right? That if you have a higher rate of saving, you're going to end up with a higher amount of capital. And so here's our slow transitioning. It's actually going to be rapid at first, but it'll take time to get from a low level of capital up to a high level. And that will be pushing us from a lower level of output up to a higher level of output. So you can get economic growth during this transition by having increased the saving rate. And so this might be a saving rate increase from, oh, I don't know, let's say maybe 10, how are we visualizing this? This is actually pretty big, right? It might be an increase in the saving rate from, you know, the ratio of this distance to the whole thing, which looks to me like possibly 20 or 30%, up to this as a ratio of the whole thing, which might be close to 50%. So you can increase your output, your GDP, by raising your saving rate. But let me just ask you a question about that. So what's happening here? We're saving 30% of our income, that's this curve. Then we decided let's be frugal and save 50% of our income, consume only half of it, and save the rest. It becomes investment. It becomes new airports. It becomes new ports with big cranes that move stuff. It will increase our income. That's very good, right? What does it do to our consumption? It actually decreases it in the short run, and in the long run, that's a little bit less clear because your income will increase in the long run. But in the short run, it's a cost, right? It's not fun to save. It's delayed fun, right? The only reason it's good to save is that it's going to get you up here. Well, that's not going to happen for a while, and in the short run, you're saving more and consuming less, and that's not so fun. So that's a rather deep insight here that is a little less clear. What can we say about the rate of growth during the transition to the new steady state? And so this is a little bit, it's a little bit of a complication that I don't think you need to really worry about as much as the basic use of the model. But this is true, and it helps explain what we see in real data. So suppose the saving rate increased, and like I said, this has been the case in China and also in South Korea. As an aside, let me just step back actually and tell you something about this. In South Korea in particular, but this may have been true in China, but I know it was true in South Korea, the saving rate in the nation rose for a rather interesting reason. It rose because family size fell. And other things happen too. But why would that affect the saving rate in this way? Well, suppose you have a very large family. Are you able to save money? No, it's because you have a lot of kids, right? You have a lot of kids and you have to spend on them. It turns out that, an age structure in the population where you've got a lot of young people, especially very, very young people, but then also a lot of young people who are then having all those babies who become young people, it tends to be kind of bad for the national saving rate. And so what had happened in South Korea was a reduction in family size, a reduction in fertility down closer to levels that we see in the United States and in Japan. Japan has actually really low fertility, but what that had done was raise the saving rate because you have fewer kids and you can afford to put money in the bank. You don't have to spend it all on diapers and Happy Meals and all that stuff. So that's kind of where all that came from. So what does this do to growth? Well, it turns out, in the short run, after the saving rate increases, we're still at this point, and I've drawn this big, thick black bar to illustrate the difference between depreciation and saving at this new rate of saving S prime. So the growth is actually very rapid because this vertical distance is so tall. I've often made it fat to kind of help you think about this. As we move, though, from K star toward the higher steady state K double star, we're going to see a big jump at first and then a shorter one and then a shorter one still. And so the width and the height of these things are drawn to kind of help you think about that. Growth is very rapid immediately after the saving rate falls. You could also think about it the following way. If we were somehow able to just dictate everybody save more, it would create a lot of growth in GDP very quickly. We don't do that in this country. Most countries don't. And why? Well, it would provide all this extra saving that would produce new investment and fuel the economy's growth. Yes, question?
Yeah, where does the graph show how consumption decreases?
Yeah, I'm sorry for raising that because it is confusing. The question is, where does the graph show that consumption is decreasing? And that's a really good question. It doesn't show it easily, but let me try to talk you through it. What is consumption? It's income that is not saved. So if you were to look for it on the graph, well, here is income. That's the level of the blue line, right? Where is saving? It's the level of the red line. So it used to be that, now it's that. So consumption has gone from being this distance here to being this distance here. The distances between the red and the blue lines. So it's hard to see that. Yeah, that's, yeah. These are very advanced concepts. People do this in great detail in graduate school, and the challenge for us in this class and in the other econ201 classes here at Queens is to try to make this a bit more manageable. But as you can see in this question, you can go very deep into the weeds with this model. You will not have to unless it's very clear how we're going to do it on the exam. So please try not to get too kind of freaked out about how detailed this thing could be. The main issue here is that you're comfortable with thinking about these curves, knowing what they look like, and in response to a question about a change in one of the parameters, suppose it's the depreciation rate instead of the saving rate. Suppose the depreciation rate were to rise. What would happen? Questions like that you're on the hook for, and you can think about how the curves shift if they do, and then what happens. That's the challenge. It's not easy, but I think you'll be able to do it with some more practice. Okay, so having shown you this now, this is the example of the saving rate rising, and it produces rapid growth in the short run in the capital stock, but it also produces this rapid movement from here up to here on the output curve. And so that's what I'm going to graph next against time on this slide. So if we calculated and plotted yt against time, this is happening in the previous graph. It's just, it's instructive to kind of look at it this way. In the old steady state, before the saving rate rises, output is just kind of hanging out. It's just constant. If the saving rate were to rise, then at this time 0, then this is what we would see, this rapid rise in output at time 0. But then it kind of levels off. The slope is showing you the growth rate here. And then the growth slackens, and you're going to reach the new steady state at y double star. The other sort of the policy implication, the interesting insight here is that if the Solow model is correct, and all that saving does is produce more capital, which is, I think, basically true, then growth in China, if all of it comes from only changes in the saving rate, growth in China will eventually taper off and slow. That's basically the prediction. It's not clear that that's going to happen, but when we look at the data, in fact, it appears that has happened multiple times in other countries. And so, it's not a bad guess. Well, let's do one more of these, or at least start it. We've got about a minute and a half remaining, and let's talk about this. Well, suppose what happens instead of the saving rate rises? Suppose what were to happen if instead the depreciation rate were to rise to some higher level? Why would that happen? It's hard to know. Maybe there is, I don't know, global warming that makes the climate crazier, and so the depreciation rate of physical capital rises because the stuff's getting destroyed. Certainly, if you look at the quality of our New York City roads recently during this crazy February, we probably have a lot more potholes, and it's probably in part because of the crazy weather. So maybe something like that were to happen, and that might raise the depreciation rate. So if something like this happens, the questions you need to ask yourself are, do curves shift? And if they do, how? And what does that do to the steady state? Well, originally, we're here at this old steady state. If the depreciation rate rises, what happens? The green curve gets steeper or pivots upward. So it'd be that kind of story. Where is the steady state after this happens? It's going to be to the left at the intersection of the red and the green curve. So down here at this K double star that's actually lower than everything. This is intuitive, right? If the depreciation rate rises, that's a bad thing. It's going to destroy capital, and in fact, it does. So there is intuition here. I admit it's not maybe that obvious. But I think with more practice, this will become clearer. So thank you. Please remember to do the problem set by Sunday night, and we'll see you on Monday.